Hi everyone. This lesson is going to be about estimating and orders of magnitude. What we're going to do is I'm going to talk you through how to estimate to within an order of magnitude a value. In the ID program, generally speaking, you just have to be close. You don't have to be right on when you're asked to estimate things like we're going to do here. So I'm going to go through a couple of explanations, a couple of definitions and explanations, and then I'm going to finish by solving a problem and showing you how I would do it, and you can take that as a guideline if you want. So first thing, orders of magnitude are just ways of expressing powers of 10. So really, it comes down to this. 10 to the power of what is close to your number. So for example, 3,475, that's close to 3,000, which is close to 1,000, which is 10 to the power of 3. So that's what we're talking about when we do orders of magnitude, is we just want to know roughly, is it in the thousands, is it in the millions, is it in the quadrillions, right? So that's where we're going to start. So that's what an order of magnitude is. 10 to the power of what is close to the number you're talking about. Now, when you're making estimations, the next thing you need to be able to do is what I would call back of the envelope calculations, or fast, rough calculations. You're not trying to get the exact answer, you're trying to figure out what the answer is close to. So this is one example. If you were going to do 2,200 times 36,000 divided by 65, there's a few different things you can do here. First thing I'm going to do is I'm going to pretend, at least at first, to ignore that and that. I'm going to get rid of my zeros and I'm going to look at smaller numbers. So really what I've left myself there with there is 2 times 36. And then I'm dividing it by 65. So 2 times 36 is 72. Divided by 65 is around 1, or you could even say around 1.2. So 2 times 36 divided by 65 is about 1.2. And now I look at what I got rid of. Well, I got rid of 10% there, and I got rid of the thousands. I multiplied by 2 instead of multiplying by 2,000. So I'm going to add 3 zeros on here. Actually, that's not the correct way to do it. Adding 3 zeros and leaving the decimal place isn't such a great idea. So instead, I'm going to multiply 1.2 times 1,000, because I took out the 1,000 earlier, so I've got 1,200. Then we have up here the 1,000 that I took out there. So I'm going to add another, or multiply by another 1,000, which is adding 3 zeros. And that is roughly my final answer. If I wanted to, well, I'll come back to that. I'll talk about that in the more close estimation. So 1, 2, and 5 zeros. So 1, 2, 3, 4, 5, 6. So we've got 1.2 times 10 to the power of 6, which is really close to 1 times 10 to the power of 6. So the answer is about 10 to the power of 6, or a million. So that's the first one. That's if you want to do a really broad, quick calculation. 2 times 36, 72 divided by 65, which is really close to 72, so it's about 1. I went to the 1.2 just for the fun, but we're talking 10 to the power of 6. If you wanted to go a little closer, some of the things you could do is, instead of saying 22 or 2,000, you could say, or 2, you could say 22 times 36 divided by 65. So in this case, what you're going to want to do is, you only do this if you want to need the calculation more, or if you're quick with the math. 22 is 11 times 2. That's how I would do this. So 11 times 36 is 360 plus 36, which is 396. So I would work from there. 396 divided by 65. Well, that's not far off from 360 divided by 60, which is 6. Okay, so that kind of thing you can throw in if you want to be a little closer. Now, an important thing to think about here is this question I've written at the bottom. Which one do you need? you're looking at orders of magnitude, you really only have to care about the broad calculation most of the time. What I would suggest is practice doing these calculations by writing down 3 random numbers, multiply, add, subtract, divide, whatever you want, estimate an answer, and then punch it into a calculator, see how close you are. And then look back and say, okay, so where did my estimation go wrong to get me this wrong answer? What's making me miss? And work on it. It just takes practice. Now, the last thing you need, last sort of skill you need for doing estimation is a little bit of practical knowledge, a little bit of basic understanding of what things look like, how big they are, that sort of stuff. So these are 4 questions I've tossed in for you to have a look at so that you can decide what kind of reference points you're going to use. That's what I do. I find a landmark close to whatever it is I'm trying to figure out. So how big is a textbook? If I want to go in imperial, I'd say a textbook is, say, a foot by 3 inches, or a quarter of a foot. If I wanted to talk about how long 10 meters is, then I might say, think about 1 meter and then extend it to 10 meters. So if I put 10 meter sticks back to back, what would that be? If I wanted to think what a mass of 1 kilogram was, I have to find a reference point for 1 kilogram. What do I know has a certain mass? Well, 1 liter of water is 1 kilogram. We've worked that out in grade 9 science. So there's one way of thinking about it. And what has a volume of 5 liters? Well, 5 liters of water. I think of a 4-liter milk bag and add a little bit. Okay, so you have to have landmarks from which you work. Okay, now, using those skills, here's how we tackle an estimation problem. This question is, what is the volume occupied by White Oak's South Campus building? Remember, you only have to do this to an order of magnitude. You do not need the exact number. It's going to be a multiple choice question most of the time, and the multiple choice question is going to have 4 different orders of magnitude that are fairly separate from each other. So first thing, how do you get it figured out? Well, in my case, if I was going to do the volume occupied by White Oak's campus building, I would pretend it's going to be a prism, a rectangular prism. So it's going to have a length, a width, and a height. And I'm going to go L times W times H equals V. That's how I'm going to figure this out. Make some estimates. I'm going to say length is about 100 meters. That's the length of a track or a soccer pitch. Might be a little bit more than that, I'm not sure. But I also have to remember that it's not going to be a completely full prism because there are going to be other sizes, or there are going to be spaces missing. Width, I'm going to say, if it's 100 meters long, it's probably 75 meters wide. And for height, well, 1 story is 3 to 4 meters, so we'll call it 4 meters. And most of White Oaks is 1 floor, but some of it reaches up to 3 or 4 meters, or sorry, 2 or 3 stories. So let's pretend we're talking about 2 stories. So 2 stories at 4 meters each is 8. On average, probably 8 meters. Again, I'm estimating, okay? Now, once I've done that, I do my calculations. So volume is going to be those 3 numbers multiplied together. 8 times 75 times 100. Well, let's move this part down a little bit. 8 times 75 times 100. 8 times 75, there's a few different ways you can do that. You can say 10 times 75 and then drop it a bit. Or you can double it. 2 times 2 times 2 is 8. So 75 times 2 is 150, times 2 is 300, times 2 is 600. So 600 times 100, I got an exact value from my estimate. Now that's 6 and 4 zeros, which is 6 times 10 to the 4. And because that's a 6, it's higher, it's closer to 10 than it is to 1 or 0. So it's actually going to be 10 to the power of 5 cubic meters. So there's my estimate. What you're likely going to see is 4 answers like A, 10 to the power of 1, B, 10 to the power of 4, C, 10 to the power of 8, and D, 10 to the power of 12. So you're going to look at that, you're going to look at your estimate, and you're going to say, I'm closest to this, so that's the answer I'm going to choose. That's it. Thanks for watching. See you in class.